Hey everyone, and welcome to my talk on writing resilient microservices with Dapper. This is Shubham from Microsoft, and that's my handle. You can find me on Twitter, GitHub, or LinkedIn. In this talk, we'll look at how chaos looks like in the real world. What are some resiliency features that Dapper brings in and allows you to apply across your applications? We'll also look at how can you Dapperize your applications and do some comparisons on the resiliency aspects of non-Dapper versus Dapper applications. So let's get started and look at how chaos looks like in the real world. We'll start this with a sample app called Whereby. Whereby is an interesting e-commerce application because it does not have its own inventory. When you ask Whereby if they have a product, it goes to availability service, which goes to another e-commerce app called Contoso and checks if they have it. And if they do, it brings in the product, brands and packages it as its own and ships it to the customer. Uh, it reminds me of Slice Line from Silicon Valley. Anyone? Uh, yeah. So in this view, we can see two services: the availability service that basically checks if a product is available or not from the Contoso API. That's an external service, and there's a product information service that looks up basic stuff about a product, be it its name, price, and these aspects, and it's in a database stored somewhere. So this is how Whereby looks like. Now let's look at a few scenarios on how things can turn out in real world. Okay. In this scenario, the Contoso API is really slow since a few days. It's taking anywhere between 0 to 10 seconds to respond. The problem is the availability service has a 5-second request timeout. So if Contoso API takes more than 5 seconds, it fails, and thus availability service also fails. That call fails, and it responds back with a 500 server error to Whereby. Uh, this is a sample screenshot from my Azure load testing dashboard, and as you can see, the error percentage is quite high. It's 40% errors, and the throughput is also pretty low, right? Because it's a slow service today, and whenever it takes less than 5 seconds, it passes on. If it passes, and if it takes more than 5 seconds, it fails. And here we see a bunch of 500 errors. Let's look at one more scenario. In this one, the Contoso API is not just slow, it fails. So every time you make a API call to Contoso, it waits for 10 seconds and then fails. It does not fail right away, it fails after 10 seconds. So the problem is that the availability service, it still has the 5-second request timeout. And each time you make a call to Whereby, which makes a call to availability service, it fails after 5 seconds. So if you make 100 calls, it will fail 100 times after waiting for 5 seconds for each request. And this is how the dashboard looks like for me. The error rate is 100% because the Contoso API is down, and you can see the throughput is pretty low, and it does consume a lot of resource because each time it goes and waits till 5 seconds and then finally fails. So it's 100% errors over here. So let's look at what are the resiliency feature that Dapper comes with, and how can you write your own resiliency policies and use in your application. Uh, you have to think about how does single failure can impact the overall quality of service for your application and impact the end user experience, and failure is inevitable. So uh, Dapper has some popular resiliency policies in place that you can configure and apply across different types of targets. We'll shortly look at what this means, and you can also scope these policies around specific applications that you want. Uh, the best part is that the application code does not know about it, and all the policies are declarative and they're decoupled from your application logic, so you can basically maintain and configure them. uh, the first policy that Dapper has is timeout. It's a pretty popular policy. uh, we saw in our previous example also that the availability service had a 5-second timeout. If it didn't have a timeout and say the Contoso API took 1000 seconds, the availability service would also be blocked for 1000 seconds. And this can really propagate and cause a lot of overhead and cause general unresponsiveness. So it's always good to have timeouts in place. And Dapper supports timeout policies. You can have different names. In this case, general, large response, and really slow are different timeout names, and each of them is associated with one particular value, which is the timeout in seconds. In this case, you can also have it in minutes or hours. So yeah, this is how timeout works in Dapper. Dapper also has a resiliency policy for retries. It comes in two flavors: constant and exponential backoff. In constant, you can specify the duration, the time between between consecutive retries, and you can also have a max retry. In case of exponential, you can specify what is the maximum interval it can grow up till. So in this case, it's 15 seconds. And then you can also say max retries as -1, which is the default, by the way. In that case, it goes ahead and retries indefinitely. Okay, Dapper also supports circuit breakers. On the right side, there's a state diagram of how the circuit breaker functions. It's straight out of the GitHub proposal. You can go and have a look at it for yourself. Uh, in the last example that we saw, when the Contoso API was not at all working, in that case the availability API was continuously making calls to the Contoso API, and the whereby API was making calls to the availability API again and again, although it was failing. In such elevated failure rate scenario, it is better to turn off the traffic to the impacted service, and once the impacted service is back healthy again, we can turn it back on. So using this policy on the bottom right, you can see how you can configure the circuit breaker for yourself. In this case, it's called external API caller circuit breaker. That's the name of the circuit breaker. And then you have certain parameters. So max request tells you how many requests can you send when the circuit breaker is half open, and you can only send these many number of requests, and that's basically used to see if the service is back up again or not. And then you have an interval. So during this period, all the counters are cleared once this interval is done. You have a timeout, which is the time between moving from the open state to the half open state, and then you can have a condition on when do you want to trip the circuit breaker. This is a CEL expression, common expression language expression, by the way. So you can use that to configure when do you want to trip the circuit breaker. So the Dapper policies that we just saw can be applied onto different targets, and these can be applications. In this case, the service-to-service invocation between the apps can have retries, timeouts, and circuit breakers. Similarly, we can do the same thing for components. Components like PubSub, state store, config stores, and both the inbound and the outbound calls can have resiliency policies applied to. And same for actors. Actually, you can do it for actors as well. In case of circuit breakers, you can target a particular actor ID, or you can target like one type and all actors across that type, or even both for that matter. Let's look at how we can dapperize our application. So in this particular example, we need a two-step process. The first one is to enable these annotations in the deployment YAML. So the first one just says Dapper is enabled. Then you have an application ID that's unique for each application, and you have some other logging related stuff here. On the right side, you see a YAML where I am updating the API URL. So my app was configured to take in a URL via environment variable and make the call to that. So it's a pretty standard configuration, right? So earlier we were using the Kubernetes service URL, and now we are using the Dapper URL. So the localhost 3500, that's the Dapper sidecar, and then you say invoke and the name of the application ID essentially, and the method, and then the method name. So this will go ahead, for example, the availability one will go ahead and call the /check endpoint on the availability app. So the functionality remains the same, but it goes via Dapper, and this entire code is available on GitHub. I'll post a link in the references that you can use to go ahead and check for yourself. In fact, there are two branches called with Dapper and without Dapper, and it's really easy to switch, and you can look at that. So let's re-explore some of the scenarios that we saw earlier, and this is the first one. In this case, the Contoso API was really slow. Now we had a timeout earlier, but what happens if we add an exponential retry in the availability service? So this is how the dashboard looks like now, and if you look at the error percentage, it's back. It's gone down to 0.67 percentage. And a couple of interesting things here actually, and if you look at the next slide, this is a small comparison. So the error percentage is down from 40% to 0.67%. At the same time, one more interesting thing is that the request per second has also come down, and this is because you do multiple retries, which means that for the same request you take more time because you're doing retries internally, and so the throughput decreases a bit. But yeah, this is a good comparison, and the error rate is really down from 40 to 0.67%. This is the second scenario where the Contoso API was failing all the time. So in this case, there's always 500 responses. And what happens if we add a circuit breaker to the availability service? Let's look at the dashboard again. So in this case also the error percentage is 100 like the previous one, but notice something different. Look at the throughput. It's really high. So if I do compare the two, the request per second has gone from 5.71 without Dapper to 86.17. which means that if you had 100 requests earlier, you would finish them really fast when Dapper is enabled, because the circuit breaker basically kicked in and it said that, always fail this request, and you don't have to wait for the 5 seconds before you return a 500 response. Let's look at my VS Code instance for a bit. And again, this is available on GitHub for you to check. But if I go to the resiliency.yaml, I can see that a couple of things. So I have timeouts in place, I have retries in place, and this is an exponential retry. I have a simple circuit breaker in place. And if you look at my targets, I have two applications configured here, the availability app and the product app. In the availability app, I have configured a timeout which maps to slow response here. It has a 5 second timeout. It goes to a retry, it maps to a retry, which is exponential back off retry. And it also has a simple circuit breaker configured. So this is all that is needed for your application to be using this resiliency policy. And all you need to do is to do a kubectl apply to apply this resiliency YAML. One more thing, the resiliency is a preview feature now. So to enable a preview feature, you need to have a configuration that basically says resiliency is enabled. And if you look at any of the annotations, you can specify what configuration to use. In this case, it's called app config, and this says resiliency is true. So that's it from my side, and you can look at these resources. This is the resiliency documentation, and this is the proposal, by the way, that you can look at and see how the feature evolved. And the code for whatever I use in this talk is available here. You can go ahead and play around with that. This repo will be public by the time you see this talk. Thank you.